morning. Today we are going to present about ARP, Address Resolution Protocol. In our group, we have Reynald, Zain, Rafa, Akmal, Bryan, Ranto, Panggabean, Simpson, and myself, Justin.
This is the table of content. We have what is ARP, how ARP works, ARP function, and types of ARP. Now we go to ARP. So ARP, or Address Resolution Protocol, is a fundamental networking protocol used to map IP addresses to physical MAC addresses on a local network. It enables devices to discover each other's MAC addresses, which are necessary for data transmission at the data link layer of the OSI unit. ARP is essential for devices to communicate within the same network segment.
How ARP works. ARP is a networking protocol used to map IP addresses to physical MAC addresses on a local network. It enables devices to find each other's MAC address, facilitating efficient data transmission within the same network segment. ARP helps devices communicate by resolving IP to MAC address mapping. This is the example of the map.
This is the function of the ARP itself. The first function is to mapping IP to MAC addresses, device discovery, catching up optimization, broadcasting ARP requests, and security. In summary, ARP's primary function is to facilitate communication within a local network by resolving IP addresses to MAC addresses, discovering device, optimizing network performance through caching, and contributing to network security by identifying potential security threats. It plays a vital role in functioning of Internet and IP-based networks.
And this is the types of ARP. The first one we have ARP IPv4. This is the standard address resolution protocol used for mapping IPv4 address to MAC address. It's the most common from ARP. And then we have proxy ARP. Proxy ARP is used when one device can send ARP request on behalf of another device. This can be useful for routing traffic when devices are on different subnets. And we have probe ARP. Probe ARP is used to check the uniqueness of an IP address before assigning it to a device. And then the last one we have public ARP. Public ARP is an ARP technique used in large-scale networks such as data centers to provide redundancy and fault tolerance.
That's it from us. Thank you very much.
Now we will start the simulation. We will need 4 PCs, 2 switches, and 1 router. To connect all the components, we are going to use the copper straight line through cable. We have made the connection between the PCs to the switches. Now we will make the labels for segment 1 and 2. In an IP addresses, we can identify a different segment by reading the third number in IP address. For example, 10.1.2.1 in a different segment than 192.168.1.1.
Now we will connect the cable from the switch to the router. While connecting the cable to the router, the switch from segment 1 will be connected to the gigabit internet 0/0/0, and the switch from segment 2 will be connected to the gigabit internet 0/0/1. Now we will give IP address labels and also configure the IP address for all 4 of the PCs.
now send a test message. Firstly, we will send a test message from PC0 to PC1. Sending this message will be successful because both PCs are from the same segment. Secondly, we will send a test message from PC0 to PC2, but this will fail because PC2 is in a different segment. And one of the reasons why we couldn't send the test message is because the port status is in the router hasn't been turned on yet. The steps to turn on the port switch will be shown right after this. Next, we will write the IP address labels for the router.
We assign the IP address for the router due to the router being connected to two cables. We will assign two IP addresses for the router. The IP address that we will assign to the router will be similar to the IP addresses to each of the segment. We will only change the last number in the IP address. For example, for the first segment, the IP address for router will be 10.1.2.3, and the second segment will be 192.168.1.3. Now we will write the same IP address as the router in the default gateway area of every PC. This is necessary for us to do in order to send messages from a PC from the first segment to the second segment and vice versa.
In this step, we will start the simulation. Firstly, open the command prompt in one of the PCs and we'll start by typing the code ARP-A. This will show us that there are no ARP entries. After that, we will ping a PC from the other segment. To ping a PC, we can write ping plus the IP address of the PC from the other segment. There are two messages shown here, ARP and ICMP. This indicates that the start of the simulation is working. Right now we see the ping message is being sent from PC0 to PC2, which is from the next segment. If this simulation is successful, then we will see a ping request get sent from PC0 received by PC2, then sent back again to PC0 as a ping reply from PC2.
As we can see here, the ping reply has been received by PC0. Therefore, this simulation is successful.